I'm sure you've heard the saying that a picture is worth 1,000 words, and artists have been using this language of drawing to express ideas and realities for a long time. And not all languages are equal when it comes to what they're good at expressing. For example, if you wanted to describe snow, the Inuit language has over 50 words to describe snow. If you were a poet or a musician, the Romantic languages lend themselves very well to sounding beautiful and expressing themselves. If you wanted to study law, Greek is a language that is very precise, where we get most of our legal terms from. And as artists, we develop different styles in the same way as people develop different languages to express different ideas. So the expressionist and the impressionist were able to show a multitude of feelings and emotions through their brushstrokes, their color choices. The photorealists were able to show extremely precise details and the accurate representations of life. The Renaissance artists were the first ones to really understand the mathematical and geometric reasoning behind accurately representing perspective. Up until this time, no one had ever really done it accurately. One of the greatest artists of the Renaissance was Leonardo da Vinci, who, of course, we know painted the Mona Lisa in The Last Supper, but was also an incredible inventor. So, looking at his drawings, you can see that it was artists such as Leonardo da Vinci who really are the forerunners to developing a drawing language which would be useful for technical drawing. As technology continues to advance, we require a more and more efficient technical language, where Leonardo took 20 lines to define a form we want to use 4. And to show you this language, I'm going to use an example from my childhood. When I was a kid, Mario first came out as a two-dimensional 8-bit plumber who traveled through pipes to save princesses. Now, as graphics got better and better, more and more detail was needed to describe Mario's world. Artists could no longer put one green rectangle on top of another green rectangle and call that a tube. We now needed to know exactly how that would look and how it would be built in a 3D engine. So let's take Mario's tube here and do some designing. We're going to do some technical drawings, and we'll learn about our technical drawing language using this as an example, because this seems like fun to me. And as we learned before, uh, if technical drawing is a language, the language is made up of words, and those words would be our lines. And since learning an entire new language in a day seems like a bit of a large task, I'm going to show you the first 5 lines in our technical drawing language, and the remaining 7 lines we'll cover in another video. So if you have your alphabet of lines sheet, go ahead and pull that out now. I'm going to break down our lines into 3 groups. We're going to have thick lines, and I'm going to list those down below here. Go ahead and notate your sheet that these lines are the thick lines. Medium lines, which really is just hidden lines, and thin lines, which contain all the remaining lines. Once you have those notated, I'm going to go through this drawing and explain what those lines are and how we use them. So right now I'm just setting up my border with a pencil. You could probably call these construction lines. I'm going to go over them with a pen as we do with border lines, because border lines are the thickest lines on our page usually, and at least as thick or thicker than our visible lines, and they're always done in pen. This is because border lines are the reference point for the rest of the drawing. If you have border lines that are crooked on the page, well, the rest of your drawing needs to be reference to those border lines. So you will do your drawing crooked. That is how that works. The edge of the page is not our reference to what is straight. The border lines are our reference. So we don't want to be redrawing our borders, so we do those in pen so as to not change the reference point. So I'm going to go through and outline that in pen now. All right, now I'm going to start with my construction lines. These are lines that are temporary line work. They're not actually a part of the drawing or the object we're drawing. They're used mostly as a reference, and we usually will erase them at the end of the drawing. So when we make construction lines, they should be nearly invisible if you're looking at it from about an arm's length away, and easy to erase. Think about them like scaffolding on a building. They go up to help build the building, but then you take it down. It's not a part of the building. They're just used for creating and positioning other objects. Now, once I have my construction lines in, I'm going to trace the edges of my object with visible lines, and these are really the meat and bones of our drawing. Visible lines are sometimes called object lines. They represent edges and corners of the object we're drawing. Visible lines are bold and clear. We always draw visible lines with a straight edge. When it's time to dimension the object, visible lines are most always the lines we dimension to. Just doing a few more construction lines here, and I'm going to draw the same tube from that was the front view. This will be a side view, which is, of course, exactly the same on a round object like a tube. Don't worry, there is a method to my madness. For now, we're going to come back to this first drawing, though, and I'm going to put some hidden lines in here. Now, hidden lines represent the edges of objects that are important to understanding the drawing, but not visible from that point of view. So from this front point of view, I want you to know that this is a tube and not a solid object. So I'm going to do that using hidden lines. These lines are helpful in better understanding the object, but we cannot dimension to them. So to make measurements on this drawing to show the thickness, I will have to do that in a perspective, in a view that I can actually see these edges. These hidden lines are good for better understanding objects, but they do not they're not necessarily as precise as other lines. They're dotted. We can't see much detail about them. It's more just to indicate that there's something important there that will probably be explained better in another view, such as this next view over to the right. Here I'm going to do what's called a section view. Now, a section view is basically like taking an object and just cutting it in half. What would we see if we cut this tube in half? Well, we would be able to see more detail than we could with just hidden lines. That's because hidden lines, like I said, they're dotted lines. They cannot show precise, intricate details. But with these sections lines, I'm going to be able to do that. So I'm going to spend a little time here and measure out some threads to this pipe. This is where one pipe might screw into another. This is far more detailed than information that I could represent with a dotted line. So I'm going to go ahead and spend a little time drawing those in with regular object lines. A solid line representing the edge that I can, in fact, dimension to. Another advantage of doing a section view. There we go. I'm just going to clean my drawing up a little bit here. And section lines are the lines I will go ahead and use to show the part of the drawing that solid material has been cut away. So since I cut this in half, it will be the solid edge of the tube on the outside. And I'm going to go ahead and tediously go in and draw several dozen diagonal lines, equally spaced, or as equally as I can, through the sides of the tube to represent that this is where the object was cut in half. Only the parts that were cut will have the diagonal section lines going through them. So this is going to take some time. I'm going to go ahead and do that now. All right, now as I finish these lines up, I'm going to prepare to start making some center lines. Center lines are a little complicated, but really all they do is they run through the center of circular or cylindrical features in a drawing. Most circular features look exactly the same as features with non-circular geometry from 2 of the 3 perspectives. This means that I have no way of knowing if these are tubes or boxes from these 2 perspectives. For all I know, these are square tubes of some sort. The only way to tell them apart is by adding center lines, which represents their central axis, and that's how we confirm that these are indeed circular objects. Another important feature of the center line is to confirm that 2 cylindrical or round objects are aligned. This alignment is called coaxial, which really just means that, for example, the wider part of the top of this tube is in alignment with the thinner bottom part of the tube. They're not on 2 separate axes. What I'm doing now is throwing some construction lines in to lay out the positioning for my overhead view. When doing the overhead view, as you see here, we use 2 center lines crossing, and the point at which they cross is the exact midpoint of a cylindrical object or hole. We can use this to draw a perfect circle if we know the radius around that midpoint to make the object. Center lines are used in dimensioning, unlike hidden lines, for example. Whenever you want to dimension a circular feature, it's best to use the midpoint as the reference. Rather than measuring from the side of the object to the side of the hole, we would measure from the side of the object to the center of the hole. And just by knowing these 5 lines, we will understand the majority of our technical drawing language. This drawing is conspicuously missing dimension lines and its dimensioning. We'll have to cover that in a separate topic because there's a lot of intricate rules that go into how to dimension a technical drawing. For now, I want you to focus on making sure you have a good grasp and understanding of these 5 lines. You understand what they do, what they don't do. You understand how to read them on a drawing and how to use them when we go to make our own drawings. And that's going to do it for this lesson. Thanks for watching. We'll see you on the next one.